I'll move on to the next thing and talk about the p block element. This is the p block element: boron family, carbon family, nitrogen family, oxygen family, fluorine family, then the halogens, right? Then the noble gases, right? These are called p block elements because the last electron, the final electron, enters into the p subshell, right? So this is the boron family: boron, aluminium, gallium, right? Indium. This is thallium perhaps. These five you have to remember over here: carbon, silicon, germanium, tin, and lead. Very, very important, right? So lead and tin come in the carbon group, right? Carbon, silicon you obviously have to remember because, right? And perhaps, right? So it's very, very easy. So from over here there is a difference of 8, then again 8, then 36, then I mean sorry 18, then again 18, then 32, then again 32, right? So if you're starting with, let's say, boron family, the boron has atomic number 5, so aluminium will have atomic number 13, right? 8 is the difference, then 31, because again 18 is the difference, right? Then it will be again 18, so indium will be 49, right? So boron, aluminium, gallium, indium, thallium, perhaps you can remember. Carbon, silicon, definitely germanium, tin, lead, right? Nitrogen, phosphorus, arsenic, antimony, bismuth, all 5 are very important. Try to remember their atomic numbers, right? And if there are any exceptions related to them, you have to remember them, right? Nitrogen family, guys, you might remember from the last class, they are pnictogens. Oxygen family are chalcogens, right? These 17 group elements, right? These are halogens: fluorine, chlorine, bromine, iodine, astatine, right? These are halogens, right? And these group 18 elements are noble gases, right? I hope you remember all this, guys. So helium, neon, argon, xenon, krypton, right? Krypton, xenon, radon, right? These are very, very important, right? These 1, 2, 3, 4, 5, 6 till radon are important, right? And try to remember, especially try to remember the atomic numbers of these guys, because if ever you have to find the position of an element in a periodic table, right? If you just remember the, because this will be, if you know, this will be 1s, this helium definitely is 1s2, right? So this is the p block does not get filled, right? But but it's still included in group 18 because it's a noble gas. So this is sort of an exception over here, but this is still a noble gas, so you must remember that this is 1s2. That's sort of an exception, so let it be over here. Then this neon, this is 2p6, this is 3p6, right? The final shell, right? The final shell configuration, right? But all, obviously there will be something before that. Then this is 4p6, right? Then this is 5p6, and you should remember the atomic numbers: 2, 10, 18, 36, 54, 86, right? 2, 8, 18, 18, 32, 32, right? Like that. 2, 8, 8, 18, 18, 32, 32, right? So if you begin with over here, the next difference will be 8, then 8, then 18, then 18, then 32, then 32, right? So if you know helium, right, next is neon, right? So you'll add 8 to that. I hope you've understood this, guys. So these are the p block elements. We've seen that in detail in the last class as well. I've given you quite a bit of a reminder, right? Of course, halogen family you can very easily remember, right? A lot of an elements, right? Very reactive, so they occur in a lot of reactions, fluorine, bromine, iodine, astatine, right? Tennessine is not important, right? Please try to remember all these things, right? I hope you've understood this, guys, and I'll move on. So in p block elements, guys, last electron enters into the p orbital. General valence shell electronic configuration, if you see, for the 13th one, which is the boron family, right? Group 13, which is boron family. This is boron family, and it all starts from here. This is boron family, this is carbon family, this is nitrogen, this is oxygen family, this is the halogen family, right? And then this is noble gases, right? Okay, so this is ns2 gets filled, then np1, this is np2, np3, np4, n5, p5, np6, guys, right? Of course, guys, metallic properties increase as we go down the group, right? In case of p block elements especially. So what happens is, guys, the ionization energy becomes low, right? So the tendency to form a cation becomes high. So but basically metallic character is the tendency to form, it's defined. So non-metals are those which can easily give out and which can easily take an electron, and metals are those which can easily give out an electron and become positively charged, right, and ionize. So if you go further away from the nucleus, right, the nuclear pull keeps on decreasing, right, hence down the group the metallic nature increases, right. I hope you've understood this, guys. Next up, d block elements, guys. D block elements we've talked about it in detail, right. So d block elements start from scandium, right. So scandium, guys, if you write the configuration of scandium, which is 21, it will be 1s2, 2s2, 2p6, right, then it will be 3s2, right, then 3p6, right. So how much have we got covered? 4, 10, 12, 18, right. Now it will be 4s2 and 3d1, right, because if you remember from the last class, the nth s orbital has the lowest energy, followed by n minus 1 dth orbital, right, n minus 1th d orbital, then n minus 2 th f orbital, then the nth p orbital, guys, right. So this d block, the final electron goes into the d subshell, right. After this s subshell is filled, only then does it go to the d subshell, guys, right. So the final electron goes to the d subshell. So for all of them, right, so for all of them, right, a lot of all of them, the final electron goes into the d subshell, guys. One more thing you should remember over here, that although lanthanum and actinium, right, the lanthanide and the actinide series, after them they are named, right. So lanthanum and actinium, guys, the valence the final electron actually goes into the d orbital instead of the f orbital, because the transition energy between d and f is very low. So you might never know that it's whether it's lying in the d orbital or it's lying in the f orbital. We are talking about just one electron in both the cases, guys, in case of actinium and lanthanum, right. That is 50, for example 57 is the atomic number of lanthanum. So we know over there that it can go into the d orbital, the final electron, or into the f orbital. It should have gone into the f orbital ideally, right, but there is just one electron. The f orbital has a larger energy, so you can understand like this. So it will just say that, you know, just one electron, I might just as well go in the d orbital instead of the f orbital, right, and it will occupy much more of a space. So that will be, you know, to keep that up, keep that system, it will be a lot more energy. So transition energy is very comparable in that case, right, between the d subshell and the f subshell in that number, for example in lanthanum and actinium. That is why sometimes they are said that they are in the d block, sometimes they are said in the f block, but definitely the probability of them going in, the final electron going into the d subshell is higher than it going to the f subshell, right. I hope you've understood this, guys. So this was about d block elements, guys. So about d block elements, guys, I told you what all to remember, right, a lot many things to remember. So definitely till 30 you should remember everything, right. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, right, you should remember that, right. After that, definitely chromium is followed by molybdenum, tungsten, right. These three are important. Molybdenum, tungsten is used as a catalyst in a lot of places, right. Molybdenum is also has a lot of uses, so that this is very important, right. Then iron, right, iron, and then ruthenium is what follows iron. So just you should remember, because iron in itself is very important. Then this is cobalt, right, nickel, palladium, platinum, very important. Platinum, palladium are used as catalysts in a lot of cases, right. So it occurs very frequently in your chemistry, so you must remember the atomic numbers of nickel, palladium, platinum, right, and their properties. Copper, silver, gold, right, you remember from this last class, right, these are coinage metals, right, or so these three you must remember: copper, silver and gold, right, they come in the same group. So if you remember copper 29, then you can add 18 and then 32, right, you get, because if you if you see the periodic table, if you see it starts from over, so for example, if I'm talking about the 18th group, it will be helium over here, then it will be neon over here. There is a difference of guys 8, right? Now if we follow it with argon, guys, right, we follow it with argon, so helium, neon and argon, so the difference is of 8, then it's of 8, then it will be of 18, right? Argon is, then the next one, which is krypton, would be 36, right? So this is 2, this is 10, this is 18, then the next krypton will be 36, guys, right? So this is a first period, second period, third period, fourth period. So this fourth period you should remember for D block very well, right? Till fourth period you should remember the periodic table at your tips. After that, you know, certain elements you can remember, right? The noble gases, you should definitely remember all of them, right? Because noble gases will give you a yardstick to determine where will some element with some atomic number lie in the periodic table, in which group and which period, right? So once you know this, you will be able to figure that out, right? Apart from that, guys, this iridium is important, right? Iridium has a lot of uses, that is important. And talking about zinc, right? This group, right? In this group, zinc, cadmium, mercury, important, right? Copper, nickel also comes over there, so you can remember that, right? And of course, these are called transition elements. The D block elements are called transition metals or transition elements, right? They are more metallic than non-metallic. They have a tendency for showing metallic character, right? So I hope you've understood, guys. So we talked about metallic character also, right? They are sonorous, they are lustrous, right? All those things, right? But chemically, if you define metallic character, it will be the lowest ionization energy, the easier, I mean, the lower the ionization energy is, the more the metallic character will be, guys. All right. I hope you've understood this, guys. And I'll move on. The last electron enters into the F block in case of F block elements, guys. So it starts with it's the lanthanide series and the actinide series, right? When we are talking about the F block elements, right? Lanthanum and actinium, guys, these two, right? The final electron actually goes into the D subshell, right? For these two, right? But for all of them, these, right? So 58 to 71 and 90 to 103, you can count 14, right? 14 is the number of electrons that can go into the F subshell, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So from cerium to lutetium, right? And thorium to lawrencium, right? These go into the F block, right? These do not go into the F block. The final shell does not go to the F block. These are mentioned over here, guys, because these are lanthanide and actinide series. So what we do is we remove that entire series, right? Which would go over there and put it at the bottom, right? So that it's more organized, right? Organization is all what we wanted from the periodic table, right? Because there were so many things coming up, so many elements that were getting discovered. We wanted some sort of an organization, and that's why we we made, in fact, a periodic table, right? I hope you understood, guys. Just organize things, right?